So today we're going over 4.1 exponential functions. Uh, Anyone know what is the mean of exponential function? Do you know any idea about the mean of exponential functions?
It grows very quick.
Yes, it growing up very quick. What else do you know about this? Like, what do you mean? Like, yes, this is correct. It grow up very quick, but can you explain more to the students?
Yeah, so exponential growth is different than the other functions because, for example, bacteria grows exponentially, like 1 to
Yes.
2, 2 to 10, 10 to 100, 100 to 1,000, 1,000 to a million, to a trillion. So it just really grows very quick. It's not
Yes,
in a
very
linear
nice.
fashion.
But it's not telling it exactly. So what is the function for this? This is
Is
called
it something
exponential
like
function.
y equal, I don't remember, is it y equals z times x to the x? That's
Z
z
times
times x to n, like a power.
n. N. Yes, cool. Uh, what is x here?
X is the
It's
rate.
a variable or number?
Yeah,
It is a variable here, or is it a number?
it's a variable.
It's a variable. If it's a variable, it will not be exponential. But if it's a number, it's going to be an exponential. Cool. Okay. And what is z here? It's a
Z,
variable or number?
it's a number. Is it the initial value, I think? Is it?
Initial value. Okay, nice. Uh, yeah, this is nice about what you said. It's growing up very fast. This is nice, correct. Uh, who can give me another definition or another idea about exponential function? Like, who can give me the different way about this as like the formula for the function? How is that if the function look like? I mean,
Professor? Um,
yes,
I I don't know if it makes sense. You ever heard of the rate of change of rate of change?
rate of change,
Rate of change
like
of rate of change.
uh, rate of change over rate. Like, how is the function look like?
I can't explain it properly. I remember a rate
Okay,
of change of rate of change. So the rate of change of the first rate of change. It's okay. It's a bit complicated. I won't be able to explain it.
no,
So
I would like to know how is the function look like? Do you
I
know?
as a, I actually don't, but I just thought you
Uh,
would know. But
yeah, I know the rate of change. I know the function. I think something like this, right?
yeah, close.
Or I know the average rate of change, uh, like the same things, like the rate of change, like we said before, is the difference between two variable over, like if I need to looking for the rate of change between 2 point b1 and b2, so the function would be like f of b2 over minus f of b1 over b2 minus b1. This is called like the average rate of change or the rate of change between 2 points. But maybe we have like different way to explain, or do you have like, is it the same like this, or it's different about what you said? So, okay, anyone see a function like this of x equal 5 to the power x, something like this? By the way, this is the exponential function. Okay, this is an exponential function. Anyone see something like this before? Or did you see something like this, a to the power x? I mean, like for a, it's a real number, it's a positive number.
Wait, what's the
So
question,
I can
Professor?
define. Did you see something like this? F of x equal x to the power 5
Oh yeah,
before?
yeah.
Yeah, this is called the exponential function. This is example of exponential function. Or did you see something like this?
Professor,
Yes.
the difference between my example and your example would be that yours starts at the origin. Mine has an y value, an initial y
One.
value.
Yes, it's one. Yes, exactly.
Okay.
So the z here is one. Like the difference is one. But this is for the this is yeah this is like modeling stuff like this. But I need like the original or the definition for not I don't want to use model like function for modeling for like growing for bacteria, for example, or growing uh, for virus or stuff like this. I need like the original function for the exponential function. That's why I start like talking about something like this, or a to the power x. So I can define the exponential function as a function of the form. So here exponential function function with base a is a function of the form f of x equal f of x equal a to the power x. This is exponential function with base a, is a function of the form f of x equal a to the power x. But here we have some condition for this function. Again, f of x equal a to the power x. We have some condition. Uh, could a be could a equal here this a? Could a equal? So we have to know this a must be a positive number. A is greater than 0, and we should to know also x here is a real number. So x here also, x is a real number, belong to the real numbers. But my question now, could a equal, for example, 1? Because 1 is greater than 0. Of x equal 1, 1 to the power x. Could a equal 1 here? Is it correct to be 1?
Yeah.
Like f of x equal 1 to the power x. Is it exponential function?
Yes.
Like this? But we know,
Actually, no, no, no,
yeah,
no.
exactly. It's no, why? Can you explain why?
I think it's a constant.
Exactly. It will be like 1 to the power x, and 1 to the power x is 1.
One.
If I plug any number, so it give me 1. So f of x equal 1, is it exponential function? Exponential function, something like this, going different. It's not a linear function. So f of x equal 1 is a constant function. How is the graph for this function? Do you know? F of x equal 1. Do you know how we can graph something like this? Is it a vertical line?
It's a horizontal line.
Horizontal, exactly. So the horizontal passing which point?
The y-axis.
Y-axis, passing the y-axis, but at which point? Crossing the y-axis at what point?
One.
At 1, exactly. So it's a horizontal line, look like this. So here, a could not be equal 1. So we're going to remove the 1. So a not equal 1. So a can be positive, but except the 1. Why? Because it's going to be a constant function if it's 1. Okay. So this is the definition for the exponential function with base a. Is f of x equal a to the power x. A is positive, x is real numbers, and a is not equal 1. Now we're going to learn how to graph this exponential function. After we know how is the exponential function look like, now we're going to graph this function. So graph of exponential function, graph of the exponential function. So I'm going to start by example by using the plotting point. As we learned before, always we start by using the plotting point, then we're going to move by using the transformation. So the example now, graph or each of the following. So first by using the plotting point, so I'm going to give example to show how we can be using the plotting point. I mean for plotting point, like making a table. So example, graph the function graph the functions. The first one is one here is f of x equal 3 to the power x, and the second function b is g of x equal 1 over 3 to the power x. Now look, this function has a base 3. This is called the base number 3, and here the base is the reciprocal of 3. Do you see 1 over 3? It's the reciprocal of 3. So I'm going to graph both of the functions f of g and g of x, and I'm going to looking for what's the relationship between these two functions. There is a relationship between these two functions, f of x equal 3 to the power x and g of x equal 1 over 3 to the power x. Here is the base is 3, and here is the base is the reciprocal of 3, 1 over 3. So I'm going to graph both of the functions, and then I'm going to looking for the relationship between these two functions. So let me make a table. Here is the table. We have to use x, variable x, f of x, and g of x. The point are 1, 2, 3, 4, 5, 6. Okay, 6 points. It's enough. So we have x, we have f of x. I'm going to use the blue color. F of x equal 3 to the power x, and we have g of x equal 1 over 3x. So I'm going to use the points -2, -1, 0, 1, 2, and 3. Okay, so at 0, what is the value for 0 for f of x? Plug the 0 here. F of 0 equal 3 to the power 0. What is the answer? What is the 3 to the power 0? What is 3 to the power 0?
1 or yeah.
Yeah, it's 1 exactly. Because 3 to the power 0, 3 to the power 0 equal 1. Anything to the power 0, always 1. Always 1. Anything to the power 0, always 1. Okay, 3 to the power 1. What is the answer? 3 to the power 1. What's the answer? 3, exactly. 3 to the power 2 is 9, correct. 3 to the power 3. Exactly, 27, correct. 3 to the power 3 means we have to multiply the 3 times. We get 27. Okay, minus 1, 3 to the minus 1. 3 to the minus 1 is 1 over what?
-1/3. No, 1/3
Yes,
is 1/3.
1 over 3, exactly, 1 over 3. The minus mean we have to flip the function. Exactly. Now, what's the minus 2? 3 to the minus 2.
2/3.
2 over 3 or 1 over 3 squared?
Wait.
When you see the minus, this is mean you have to put it in the denominator.
Oh,
So it's going to be 1 over 3 to
Mhm,
square,
mhm.
okay? So 1 over 3 square, how much?
1/9.
Yes, 1 over 9, correct. Now let's doing the red curve, the red function, the g of x. At 0, 1 over 3 to the power 0, how much? Always, anything to the power 0 is 1, always. So the answer here is 1, exactly. Now, for minus 1, 1 over 3 to the minus 1, how much? 1 over, I'm going to do it here. 1 over 3 to the minus 1. It's minus 3. No, it's not minus 3. It's 3 positive. Why? Because the minus here, when you go inside the parentheses, will change the numerator to the denominator and the denominator to numerator. So I will get 3 to the power 1. Now 3 to the power 1 is 3. So here is the answer is 3. Now 3 to the minus 1 over 3 to the minus 2. Exactly, it's 9. Same idea. The minus, it's going to change the numerator to denominator. So I'm going to get 3 over 1 square. And this is equal 3 square over 1 square. 1 square is 1, so I will get 9. Exactly. So here is the 9. What about the 1? 1 over 3 to the power 1 is 1 over 3, correct. And square, 1 over 3 square will be 1 square, 3 square is 1 over 9. Yes, 1 over 9. And 3, 1 over 3, everything is 3. I'll get 1 over 27. 1 over 27, correct. Yes. Okay, let's see graphing the both of the function. Both of the functions. So here's the Cartesian plane. Here is the x-axis. And this is my y-axis. Okay. So now let's starting doing the blue one, but I will mark the x-axis. Here is 1. This is 1. This is 2. This is 3, 4, 5, 6. Here's minus 1, minus 2, minus 3, minus 4, and minus 5. Here I will moving so here I have 0. I mean 1, 0 here, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So let me start doing the one. So at 0, I will get 1. So 0 and 1. So this is the first point. 0 and 1. Here is the first point. Now, at 1 is a 3. So here is the 1. And here is the 3. 1, 2, 3. So the point should be here. Okay. At 2 is 9. Here is 2. And here is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. So here is the point. Now, at 3 is here. At 3 is 27. We don't need it. It's so far up. I need -1 to the 1/3. So here is the -1. And 1/3. So it's less than 1. So this is 1. Here is 1/3. And at -2 is 1/9. 1/9 is smaller and smaller. So the curve will be close to the x-axis, but will not touch the x-axis. It's not going to touch the x-axis. So this is the curve. So now I can graph the function f of x equal 3 to the power x. So this is the first point. No, it's not like this.
Wait,
So this is the graph.
sorry, we can't see the x-axis.
Oh, you cannot?
No.
No, okay. You cannot see. You can see right now? Or the same thing?
Yes.
You can?
Yes.
Okay. Okay, this is the curve for the blue curve for the blue function is f of x. This is the f of x equal 3 to the power x. You have to know the function crossing the y-axis at this point. This point is 0, 1 always. Okay. The blue curve must cross this point. This point is 0, 1. Here is 1. Now let's doing the red curve. So the red one, okay, at 0 is 1. Both of them the same thing. So at 0 is 1. So this is the first point. At 0 is 1 here. This is the first point. The second point at 1. I'm going to take the -1. At -1 is a 3. So here is -1. This is the point is -1. So at -1 here, it's going to be 3. Here's the 3. Okay. Now for the second one. At 2, -2 is 9. At -2, it is 9. At -2, here is the -2. It's going to be 9 here. And at 1 is 1/3. Here's 1 over 3. It's less than 1. At 2 is 1 over 9. Here is the 2. And here is the 1 over 9. Close to the 0. But will not touch the 0. Okay, let's now graph the blue curve. Here is the graph. Okay, the red curve will not touch the x-axis. Will move slowly close to the x-axis here, but they will not touch it at all. And the same things here. For the blue curve, the f of x will be close to the x-axis and they will not touch it. Both of the function, they're passing 1 point. What point is this? What the point both of the function they pass it? Is 1. 1 and what? It's 1 and the y-axis, right? What is the order pair for this point? What's the order pair?
0.
0 and what? 0, comma?
1.
Comma 1, exactly. So it's 0, comma 1. Both of the function passing this point is 0, comma 1. And also in the same things, both of the function will be close to the 1 and they will not touch the y-axis. So what you see here, what's the relationship between the blue curve and the red curve?
Inverses.
Inverse or
Yeah.
reflect? Is reflected or inverse?
I think I'll say reflect. Yeah, reflect.
Reflect around which axis, as you see?
The y.
Y-axis. So the graph of this and the graph of this are like reflecting around each other around the y-axis. So my y-axis is my mirror. So here is my mirror. This is my mirror. Look, if you want to reflect the blue curve, it will be the red curve. If I want to reflect the red curve, it's going to be the blue curve. So both of them are reflecting to each other. Both of them reflecting to each other around the y-axis, around the y-axis. So here, the relation between this and this is g of x is reflected up around the y-axis of the function f of x. So here I can say the function g of x here, the function g of x equal 1 over 3 to the power x, and this is equal. I'm going to take the 3 from the denominator to the numerator, so it's going to be 3 to the power minus 1, everything to the power x, and this is equal. We multiply both of the exponent here, 3 to the power minus x. So actually my function g of x first of all, let me write f of x. My f of x equal 3 to the power x, right? And g of x equal 1 over 3 to the power x. So if I need to graph the g of x equal 1 over 3 to the power x, and this is equal actually 3 to the power minus 1 multiplied by x, and this is equal 3 to the power minus x. Now, if I plug in front of this function, instead of x, the value minus x. So f of minus x equal 3 to the power what? Minus x. This is correct. Instead of x, I'm going to put a minus x. So here, minus x. So this is actually g of x is the same as f of minus x. So this is equal f of minus x. So this is mean if I want to graph the function g of x, I will graph the function f of x, the original one, then reflect it around the y-axis. So to graph g of x, we graph f of x, then reflect the reflected around the y-axis. This is very important. Is it clear what we did here? So now we know what is the relation. Can you please explain only this part? Okay. So the function g of x equal 1 over 3x, right? Now this, I can change it to the 3 to the minus 1, because as we know before from previous slide, anything 1 over 3, if I want to change it to make this moving up, this is equal 3 to the minus 1. And again, 1 over 4, this is equal 4 to the minus 1. If I want to move this to the up, I have to put the minus exponent. It's clear? So if I want to move the 3 to the up, to the numerator, I have to choose the minus exponent. Now, because I have exponent inside parentheses, and I have another exponent, we have to multiply this both together. So I get minus x. And this actually equal to the f of minus x, because here if you substitute instead of x the variable minus x, you will get minus f of minus x equal 3 to the minus x. So f of minus x equal 3 to the minus x is the same as g of x, because here g of x is equal 3 to the minus x, and it's similar to this. So this is equal f of minus x. And this is the same like this. So actually here, to graph the function g of x, we have to graph the function f of x without the minus. Then we have to reflect it around the y-axis. The minus inside the parentheses means we have to reflect it around the y-axis. Okay, Mayasha? So again, just you have to know this. This is like a review from before, if you forget. So to move any number from the denominator to the numerator, we have to use the negative exponent. Okay, so now I'm going to give you the general graph for any exponential function. So after we know how to graph these two things, I'm going to give you the general graph for any exponential function. So the graph.
Professor,
Yes.
I just have one little thought. Is it possible that you can take the time limit of the homework?
Take
Because
out?
huh?
What do you mean take?
I mean,
Unlimited? I make it unlimited without time?
yeah, because then it helps me, because it helps us, so we can go back every time, and even though we don't get it on time, then we lose it completely. And I would love to study before the exam, please, if that's.
Okay, graph of exponential functions. So we have to know now there is two kind of like the graph of the exponential functions will be fixed for two kinds. So the first one the first function, if my function is f of x equal, for example, a to the power x, such that this a is greater than 1. So the exponential function has a graph like this, always passing this point. This point is 1, 0, and 1. So it's 1 in the y-axis. So the graph should be something like this. So this is the graph for the exponential function f of x equal a to the power x, such that a is greater than 1. For example, for this f of x, who will give me example for this? Anyone can give example?
What one?
No, a is greater than 1.
Okay. 2
To the power what?
power to the
X.
x.
Yes. So this function always has a graph like this. Another example, f of x equal 5 to the power x, 10 to the power x, 1.1 to the power x. So all of them have the same shape, same graph like this. Now, if the function look like, if the function is f of x, here f of x equal a to the power x, and this a is between 0 and 1. So the graph should be something like this.
And professor,
Yeah.
it will never be under the x-axis, right?
Yeah, they will not be, they will be under the x-axis if they multiply by minus from outside.
Okay. Okay, and it will still apply the
Will
same.
reflect, I mean, like we're going to reflect it around the x-axis. Understand?
Right.
I will show you. So this is the graph of, this is the two cases for the function, for the exponential function. Who will give me example for this? For this? Who will give me example for this function?
Negative 0.5 to the
No,
x.
the a is between 0 and 1.
Oh, 0.5 to the x.
Yes, like 1/2. 1/2 to the power x. What else? 1/3, exactly. 1/3 to the power x. 2/3, yes, correct. 2/3 is less than 1, correct. And you have to know this point is 1, and this point is the same thing as 1. So the function passing this point 0, 1 most of the time. If it's of the form this, always passing this point. Now, what is the domain and the range for both of the functions? My function, what is the domain here? And the range too. What's the domain and range?
The domain is positive infinity. Oh, wait, is it?
What values can I plug in this function instead of x? What numbers can I plug, for example, negatives? Like f of x equal 5 to the power x. Can I plug negatives? Negative numbers like -1.
No.
F of -1 equal 5 to the -1.
I think yes.
Yes, because f of -1 is equal 5 to the -1. And what is that equal? 1
Oh,
over what?
1/5 over x.
1/5. So they will give me a value. Can I plug 0?
It has to be greater than 1. Is that what it is?
No, the a must be greater than 1. But the x, I plug negatives, they give me answer. So it's fine. The a, this is the a, the 5. Okay? The a here must be greater than 1. Now let's see let's see plug in 0. So what I get? F of 0, what?
1.
It's 5 to the 0 is 1. So they will give me answer. What about the positive, like 1, for example? F of 1. 5 to the power 1.
It will give you an answer.
So they will give me answer. So the domain is all real numbers from minus infinity to positive infinity. I don't have any issue for all real numbers. If I plug inside the function, will be good. Yes, the domain is all real numbers. So actually, this is my domain. Now, what's the range? What is the answer? The output. As you see in the graph. What's the output? The curve here will be close to the 0, but they will not touch the 0 at all. I mean, to the x-axis. This curve from this side will be close to the x-axis, but they will not touch the x-axis. So this is the range, right? All this is the range, but they will not touch the 0. So it will be close to the 0. So what is the range now? Because all values, all x, they give me a y value. Here is the y value. At this, they give me a y value here. At this point, my y value is here. At this point, the y value is here. At this point, the y value is here. At this point, for example, the y value is here. So what is the range? What's the range? Is it from the 0 to where? To infinity. It's from 0 to infinity. The 0 is including? No, it's open because the curve here will be close to the x-axis, but they will not touch the x-axis, so the 0 is not included. Make sense? Now for the second function, what is the
Wait, wait,
domain
so,
here? Yes.
so why is negative infinity not included in the range?
The
un-
infinity always is not included.
But it goes down all the way
You
down.
can never include infinity, no matter what example, or I think, right?
Exactly. Yes. So the infinity will not be included at whatever the value. I mean, like minus infinity always open parentheses, and the infinity always
No, that's not what I'm talking
open
about. Like
parentheses.
I'm saying, why is it 0 and infinity instead of negative infinity?
Ah,
Infinity?
okay. Okay. So why it's 0? So we start like you have to look into the green. You see the y-axis, which y is used. So at this point, for example, the y is used is this. At this point, it has this x-axis, this point, it's x1, comma y1, for example. This is x1, and this is y1, for example. So this y is used. At this point, the same things. This y is used, y2, for example. This is x2, y2, for example. This is my x2 here. So this x2 using this y2. This x use this y. At this x using this y. This x using this y. This x using this y. And the same things here using this y. This x using this y. This x using this y. So this is mean all numbers starting from the 0. It will not be the 0 exactly, because no one of the x's will give me 0. So starting from the 0 goes to all the values to the infinity. You have to ask yourself, what's the y value we use it for graphing this function? The range is for the y values. The domain is for the x values. You have to ask yourself from the graph, what x values we use it to graph the function. So as we see in the graph, all x values, we use it to graph the function, because at all values of x, we use to graph the function. Does not have any problem or issue. But for the range, you have to ask what y values is used. If you look in here, the y value is this. At this point, the y value is this. The same things for all points in the curve. All points in the curve, they're using the y values starting from the 0 to infinity. Make sense? Clear? Y to the infinity, because starting 0, here is 1, here is 1, here is 2, here is 3, here is 4, here is 5. So all of the numbers are increasing, going to the infinity. Make sense?
Yeah,
All the
makes sense.
numbers is increasing, 1, 2, 3, 4, 5, 6, 7, and the curve here is continuing, is not stop. It's not stop, going up to the infinity. The curve
Yeah.
here going
Thank you.
up to the infinity. Yes. Yes, if the y values is negative, yes, from 0 to negative infinity. This is correct, Mayesha. Now in this function, what is the domain? What's the x values we use it? What's the x values did we use to graph the function? Here, we use it. If all this point, we use it. And also the 0, we use it because we graph this point. And if we continue also to the right,
Um, is it from negative infinity coming from
to,
negative infinity to
to infinity.
positive?
Yes, correct. All these values is the domain for the function. So it like, so here's the domain would be from minus infinity to infinity, or you can say the real numbers. Now, what's the range? What's the y value we use it to graph this function?
It's coming from negative infinity. Is it also all real numbers?
Yes, we use the negative infinity. We did not, the curve does not, like the curve does not use any value in the y negative. Look, the curve, using only, if you look into the curve here, the curve using only the positive y values. At this point, for example, the y is this. At this point, the y is this. At this point, the y is this. So the y we'll use it for the range is all this y's. But except the 0. The 0 does not have any value. Yes, the range is the same. So the range will be from 0 to infinity. Yes, from 0, at the 0 is open, to infinity. Here, the 0 is open. Now, what is the asymptote? The asymptote is a horizontal line. What is the horizontal asymptote? It's a horizontal line such that the curve will be close to this line, but they will not touch it. So what is the horizontal asymptote? Can you explain why the zero is not included? Because the function here, as we see, will be close to the x-axis, but they will not touch the x-axis at all. If they touch the x-axis, the zero will be included. But actually, the curve will not touch the x-axis as we see here. And the same things in this side. You see this side? The curve will be close to the x-axis, but they will not touch it. That's why the zero here, they does not have a y value, is not included. Yeah, go ahead, Eamon.
I just wanted to say it's true for all exponential. It will never, it will come so close to the x-axis, but it will never touch it.
Yes, they will not touch it at all. Correct. What is the horizontal asymptote? What is the line such that this line, the curve will be close to it, but they will not touch it? What is the equation of this line? Because it's a horizontal, so the equation will be y equal, right? Y equal, like this. What is equal what? What number, what line, y equal, what line, what value I have to put here to be my horizontal line asymptote?
I'm not sure, but is it 0?
Yes, it's 0. Exactly. As we see here, the 0 here, this line here, this is my horizontal line asymptote, actually. The curve will be close to this line, the x-axis, but they will not touch the x-axis at all. And the x-axis has equation y equal 0. Y equal 0. So this is my horizontal line asymptote. Make it smaller. Here's my horizontal line asymptote. This is my horizontal line asymptote. So, and I like to be like this. This is my horizontal line asymptote. Now, what is my horizontal line here asymptote? For the second one, same things exactly. Y equal 0. Y equal 0. So this is very important too. You have the asymptote means what I mean, like it's a horizontal line such that the curve will not touch it, will not touch this curve. So this is my horizontal line asymptote, and here is my horizontal line asymptote. Any question? Okay, if there is no question, we're going to use, I'm going to make it, can you explain why is it 0 a bit? Oh, okay. So my question, why is 0? Why equals 0? So if I ask you, for example, look, Eric, if I have my Cartesian plane like this is my Cartesian plane. And I would like to graph a line like this, the red one. And this curve passing this point, it's 3, for example. What is the line? What is the equation of the red line? What is the equation of this red line? Can you tell me what is the equation of the red line? Y equal 3. So the equation of this line, y equal 3. Okay, if this line goes down to the x-axis like this, what is the equation of this line now? Y equals 0. Correct. Nice. Now, go back to my question. This curve, the black curve, you see the black curve? In this side would be close to the x-axis. It close so much, will be like so close, but they will not touch the x-axis at all. Like they will
Like
be
exponentially close.
exponentially close, but they will not touch it at all. So the line, the horizontal asymptote, the horizontal line such that the curve will be close to it, the curve will be close to the line, the horizontal line, but this line, I mean, like the curve will be close to this to horizontal line, but the curve will not touch this line is y equals 0 at this point. The same things in this curve. This curve in this side will be close to the x-axis, but they will not touch the x-axis. The x-axis is a horizontal line, and in the same time is calling horizontal asymptote. This horizontal asymptote has equation. The equation, like you said, is equal y equals 0. So y equals 0 is a horizontal line such that the curve of the function will be close to it, but they will not touch it at all. Make sense? You're welcome. So now example. So my question is find the exponential function f of x equal a to the power x, whose graph is given like this. It means which point the y is not going to touch the x-axis. Yes, Mayasha. Which point of y? No, it's not the x-axis. It's not exactly like you think. You have to ask yourself, what line? Suppose this curve, I will move it 1 unit to the up. You have to ask yourself, at what line, horizontal line, such that this curve in the end of the exponential function will be close to it, but they will not touch it. At what line, what horizontal line I can make it such that this line will be like that, such that this line will be horizontal, and the curve in the end point of the curve will be close to it, but they will not touch this my horizontal line. Like this, you have to think. Find the exponential function f of x equal a to the power x, whose graph is given. So suppose my graph look like this. And here's the second curve. And the graph of the function is something like this. And this graph is the function, the exponential function, and passing a point. This point is 2,25. 2,25. And the curve always passing this point. This point is 1. What is the equation? What is f of x? F of x equal to the a to the power x. My question is, what is the value for a? For the second curve, suppose my function looks like this. And this curve also the same thing, expressing this point. This point, for example, is 3 at x, 3, and the y value is 1 over 8. 3 comma 1 over 8. The function f of x equal a to the power x. What is the value for a? Exactly. Here, for the first one, a must be positive, and the second one, a must be negative. I mean, like less than 1, between 0 and 1. Nice, Mayasha. Yes, this is correct. For the first one, a must be greater than 1. And for a here, must be between 0 and 1. But what is the exact value for a? So they give me 2 and 25. What does that mean here, 2 and 25? How can I rewrite these things by using the function?
What was the question?
How can I rewrite this point by using this function? Or I can say f of 2 equal what?
Oh, you could say f of 2 equals 25.
Yes, f of 2 equal 25. Now plug this point inside this function to find the value for a. F of 2 equal what? Plug the 2 inside this function.
So 2 to the
A to the power
A
what?
raised to the power 2.
2. And this is equal, f of 2 equal 25 actually. So f of 2 equal a to the power 2 after you plug inside this function. And this is equal what? 25.
So a is equal to 5.
Exactly. Now you have to rewrite the 25. Give me a number raised to the power 2. They give me 5. They give me 25. Give me a number. This number raised to the power 2. They give me 25. It's 5. So this number actually is 5. So this is 5. Now, comparing this to this, what is the value for a? 5. So the function f of x equal 5 to the power what? 2. The power x. This is my function. F of x equal 5 to the power x. Now, what's the given point here for the second one?
F of
This
3
one.
is
What does
equal
that
to
mean?
1/8.
Exactly. F of 3 equal 1 over 8. Now, I have f of x equal a to the power x. I plug inside this function 3. What's the answer?
F,
A to
F
the
of 3
power.
is equal to 1/8. Oh, you're doing it different. Okay,
Yes,
so
exactly.
a to
And
the
this is
3.
equal what? F of 3 actually
A to
equal
the
1
3
over.
equals 1/8.
Yes. Now
Is it
raise
1?
this. Yes, go ahead.
Is it f of x equals 1/2 x?
1/2
No, not
x.
1/2 x. Sorry. Yeah, 1/2 x. Is it?
So a is equal 1/2.
Yeah.
This is correct. A equal 1/2. You ask
1/2
yourself, yes,
parentheses x.
parentheses x. Yes, this is a. My f of x equal 1/2 parentheses x. If you want to think in a different way, you have to ask yourself what number I put it here raised to the power 3. Give me 1/8. 1 over 8 is 1 over what? 2. 1 over 2 to the power 3, they will give me 1 over 8. And now comparing this to this, the exponents are the same, so the bases must be the same. So a equal 1/2. So f of x equal 1/2 to the power x. This is my function. Any question? Okay, now we're going to graph. I did not understand how 2 and 25 is equal. Okay, look, Mayasha. You plug the 2 inside the function here. So actually, I have the point 2 and 25. F of 2 equal 25. So f of x equal a to the power x. I need to find the value for a. So f of 2 equal a to the power 2. And this is equal 25. Why? Because f of 2 equal 25 is given. This is given. This point is given. So after I plug the 2 inside this function, I make it similar to 25. Now you have to write this one, the 25, in different way. What number I raise it to the power 2, they give me 25. So the answer is 5, because 5 square or 5 to the power 2, they give me 25. So a must be equal to 5.
I think I have I usually I remembered it this way. Like you see 2 and 25. First tackle the x value. So what number, if you square it, gives you 25?
Yes.
That's 5. Here on this side, what number that is power to the 3, first tackle x. So what number power to the 3 gives you 1/8, 1/2. So I think it's easier to see that way if you're not comfortable with the setting up the equations and stuff. I remembered it that way, so I thought it might be easier.
Yeah, exactly. Nice.
Think of the x as the exponent, and what's the value under the exponent that gives you the y value.
Yeah, like he said, we hide this thing here. We're going to hide this. You ask yourself, what number I raise it to the power 3, they give me 1/8. So the number is 1/2, because 1/2 to the power 3 will give me 1/8. Here the same things, I'm going to hide this. What number I raise it to the second power, they give me 25. 1 square is 1. 2 square is 4. 3 raised to the power 2 is 9. 4 square is 16. It's not 25. 5 square is 25. So the A is 5. But for this one, we have to think, what number, if I raise it to the power 3, they will give me 1/8. The best number is 1/2, 1/2. Because 1/2 raised to the power 3, they give me 1 to the power 3 is 1, and 2 to the power 3 is 8. Now, graphing by using transformation. Now we're going to learn how to graph any function, not without using the plotting point, by using the transformation. Okay, so the example is like this. Example. Use the graph. F of x equal 2 to the power x. To sketch the graph of each function, the first one, and then state the domain and range and asymptote.
Is it 2 to the x or just 2?
2 to the x. So the function is f of x equal 2 to the x. Here is the x. To sketch the graph of each of the functions below, and then state. So the first one is g of x equal 1 plus 2x to the power x. Second one b is h of x equal minus 2 to the power x, and c is d of x equal 2 to the minus x. How I can graph the first one? What is
The
my
first one,
original function? Yes, go ahead.
the original function, it always has a beginning point of 0, 1. So
Okay. So what is my original function? Is f of x, right? 2 to the x. This is my original function. Here is the starting point. So I have to graph this function to start.
yeah. Wait, so yeah, so its starting point is 0, 1, right?
0, 1, yes. Then what I should do?
0, 1, and then it's positive, so it's gonna extend. It's gonna come from negative infinity to positive. It's gonna become like a real number. Solution.
So what does that mean? No, Eamon, what does that mean when you add 1 to the function? What does that mean?
That's the y-intercept. I don't know.
No, we have to shift. We have to shift it, right? Up or down, left or right, right?
Right.
Let me explain it more, and I will make it more easy. So my original function is f of x. F of x is equal to x. This is my original function. Here is the starting point. I have to graph this.
Yes, I see.
First.
I see what you're saying. I see what you're saying. So it's
Okay.
gonna be instead
Nice.
of 1, it's gonna be 2, 0, 2, right? I think.
Yes. Is 0, 2, exactly.
0, 2, because original function is 0, 1, and then if you translate 1 up, it's gonna be 0, 2. So you start at 0, 2. I understand.
Yes, exactly. But I will show you how we can like graphing this function step by step. So before I using the O of x, now today I'm going to use the f of x. You remember when I used the O of x, means the original function? Today I'm going to use the f of x because it's giving me, starting from this function, f of x equal 2 to the power x. So I'm going to start like this. Now I have to modify for this function to make it similar to this. What I should to add? Add 1, right?
Yeah.
So if I add 1 to the both side, I will get f of x plus 1 equal 2 to the power x plus 1. And this function is the same as this one, similar exactly. So this function is g of x. So to graph the function g of x, I have to graph the function f of x is 2 to the power x. Then I have to add 1. Adding 1 outside the parentheses, outside the function, this is mean we have to shift the function 1 unit to the up. This is just a review. So here is the function. Here is 2 to the power x, this point, and this is 2 to the power x. This is f of x equal 2 to the power x.
So
Now
we
we
always have
have,
to.
yes, go ahead.
From an original function, we always have to remember to add 1 to it because it already starts at 1.
Yes. We have to shift. Yes, go ahead.
And this value is 2 where you wrote 1, right?
Yes, this is 1. It's everything will shift it 1 unit to the up. All points in this curve will be shifted 1 unit to the up. Like this. This is 1 unit to the up. 1 unit to the up. Here, 1 unit to the up at every point in this curve. So my asymptote is actually is 0, 0 for this function. I mean y equals 0. Now in this function is y equals 0, but we're going to shift it 1 unit to the up. So it's going to be y equal what? 1. Here's my asymptote. Y equal 1.
Isn't it supposed to be y equal 2?
Y equal 1 because we shifted 1 unit to the up. The
Yeah.
original one for f of x equal 2x, the asymptote for this function is y equals 0. But when we shift it up, everything 1 unit up, so the asymptote would be y equal 1. So this is my asymptote, y equal 1. Next, go ahead.
And is it because when you shift you can imagine the new x-axis is this line, so it will never touch this line, but it will.
Exactly.
Yeah. So.
Yes, nice. Yeah, like when you shift, like you have to shift everything 1 unit to the up. So the x-axis, this is my x-axis. And we know the curve will not touch the x-axis. And the equation of the x-axis, the horizontal line, is y equals 0. So when you shift 1 unit to the up, so the x-axis will be moved 1 unit to the up. So my horizontal asymptote is y equal 1. Now this point is 1, right? 1 and 0. 0 and 1. So this point will be moved up 1 unit.
Just imagine the x-axis also moves up with it.
Yes,
the x
everything
value.
will move. Yes,
Yeah.
everything will move up. So this will be 2. This point will be here. This point will be here. So all points will be something like this. And the same things for this side. Will be close to the asymptote, but they will not touch the asymptote. The curve, the blue curve, will be close to the asymptote, but they will not touch it at all. So here is the curve. See the curve will be close to the asymptote, but they will not touch the asymptote. Okay, the blue curve is my new curve. It's f of x equal, I mean, it's g of x. G of x. G of x equal 1 plus 2x. What is the domain for this function? Domain. And also, what is the range?
The domain.
What's x value we use it for this function to graph the blue curve?
All real numbers.
All real numbers. We use it to graph the blue curve. So it's R, exactly. So the answer is R. What's the range? What's the y value we use it to graph this function, the blue curve? What y value we use it to graph the blue curve?
Is it not including 1 and all and in positive infinity?
Nice. From 1 to infinity. Starting from 1, because this curve, as you see, it's my horizontal asymptote. So the curve will not touch it, but they will be close to this curve. So starting from this curve, from 1, but they will not be included the 1 to the infinity. Nice. The second equation. My function, original function, is f of x equal 2 to the power x. How I can modify this function to get something like this? What I should to do?
You multiply negative one, multiply the outside by negative
Negative
1.
1. So I will get negative f of x equal negative 2 times x, 2 to the power x. Now it's equal to the h of x. This minus 2x is the same like here, and this is equal h of x. So to graph the function h of x, we have to graph the original function f of x, then we have to reflect it around the x-axis because we have minus outside. The minus outside the function, this is mean we have to reflect the original function around the x-axis.
And
so here's my
Professor,
x-axis.
if the negative is on the exponent, then we reflect it over the y-axis, right?
Yes, exactly,
Okay.
around the y-axis. So here's the curve. Now, what is my original function is this. This is my original function. Will be close to the x-axis, but they will not touch the x-axis. This point is 1.
So you go down to negative
now,
1, which is the same distance from the origin, and then you flip it.
Exactly. So here we have to flip everything around the x-axis. So I'm going to move this one up and moving here, moving this. I'm moving here up a little bit. So this is my original function, the black one. Okay, now we're going to reflect around the x-axis because my mirror, it's my x-axis, because we have minus here. The minus, this mean we have to reflect around the x-axis. So here is the x-axis, my mirror. Now all the points will be reflected. So this point is 1, so it should be minus 1. And all the points here will be reflected, so it's going to be something like this. So what is my asymptote?
Y equals 0.
For the red curve, y equals 0, exactly. So here's the asymptote is y equal 0. What's my domain?
The domain for the original function or the new one?
For the new one, the red one.
It's gonna be from negative infinity. Wait, the domain or the yeah, from the negative infinity to positive infinity.
Yes, so it's the real numbers.
Yeah.
So the domain is R. What's the range?
Range is not including 1 to positive infinity.
For the red one.
Yeah. Yeah. So negative 1 to positive infinity, not including.
From the 0 or from negative 1?
Negative 1? No.
What about this value is minus 1/2? This point here has a y value minus 1/2. And this point here has a value minus 1/8.
Right.
So it's supposed to be 0
not including to positive.
Minus infinity.
Wait, minus or positive?
Minus infinity. Because all the value for the red, I'm talking about the red curve. See the red curve? Here we have minus 1, minus 2. No, I'm going to fix it. Here we have minus 1. Here minus 2. Here minus 3. You see the red curve? They're using these values. The y value for this is here, minus 2/2. The y value for this is minus 2. The y value for this is minus 1/2. The values for this, it's like minus 1/2. Like all of them using this y's, using this. But for this here, using this from the down. I mean, it's starting from the 0, this point, and this is not included, to the infinity. Who will do the third one? C. What's how can I get off the C?
C is basically a reflection over the y-axis.
Exactly.
Yeah.
So my original function is f of x equal 2 to the power x. I need to change it to similar to this. I have to modify this one. So I have to plug the minus x inside the parentheses. I will get 2 to the minus x. So this is equal d of x. So f of x, f of minus x is d of x. So to graph the function g of x, we have to graph the function f of x, then we have to reflect it around the y-axis. So let me do the last one, then we're going to finish this class. So here is the graph. So the original function is this. This is f of x equal to the power x. Now we have to reflect around the x-axis. So here is my reflection. This is my mirror. This is my mirror. So the point should be here, the same point, and all points here is down, and here is down, like this. This function is d of x. Okay, any question for these things? Any question?
No.
Okay, we're going to stop up to here today. I see you next week. Have a good day.
Professor, anybody got 100 in the last exam?